Let's see this question. We have already seen this question in total probability. Again we shall see it here. Let us assume that we are having a bag, two bags. Let's say this is bag A and bag B, and bag A is containing 2 red balls and 3 green balls, and bag B is containing 3 red balls and 2 green balls. Now we are conducting an experiment in which we first draw a ball from bag A and we add it to bag B, and then we draw a ball from bag B. Earlier we have seen what is the total probability that the ball that we draw from the second bag happens to be a red ball. That is what we have already seen. Now we shall see the reverse probability. Now what I wanted is, given that we have drawn red ball from the second bag, what is the probability that the first bag also, from the ball that we have drawn from the first bag also happened to be red ball? Okay, so now what is that I am asking? See, in this one we are conducting this experiment. Earlier also we have seen the question, right? So we are going to have an experiment conducted, and in which we are going to draw one ball from this and we are going to add to this one, and again we are going to draw one ball from that one, right? Therefore, what are all the events that will be present in the sample space? From the first one we might draw red ball, and from the second one we might draw a red ball, or from the first one we might draw a red ball, and from the second one we might get a green ball, or from the first one we might draw a green ball and from the second one we might draw a red ball, and from the first one we might draw a green ball, and from the second one we might draw a green ball as well, right? And earlier, while finding out what is the probability of getting a red ball, which means this one, probability of R2, getting a red ball from the second bag, we have used the total probability theorem, in which we divided the sample space based on what happens for the first ball, and then we have applied this total probability formula for this event. That is what we did earlier, right? So earlier, if you remember, the formula that we have used is probability of getting a red ball from the second bag is equal to probability of getting red ball from the first bag and probability of getting red ball from the second bag, plus probability of getting green ball from the first bag and probability of getting red ball from the second one. Got it? And in order to solve this, we have used the total probability theorem, so which is probability of getting a red ball from the first one and then probability of getting the red ball from the second one, given that we have got the red ball from the first one, plus probability of getting the green ball from the first bag into probability of getting the red ball from the second bag, given that we have got the green ball from the first one. Got it? And these numbers we can easily get. So what is the probability of getting red ball from the first one? It is nothing but 2 by 5, right? So what is the probability of getting the red ball from the second one, given that we have got the red ball from the first one? In case we got the red ball from the first one, we are going to add it to this bag. Therefore, the number of red balls are going to be increased by 1. So total number of balls is going to be 4 plus 2, and the total number of red balls is going to be 4. Therefore, it is going to be 4 by 6 plus probability of getting a green ball. So what is the probability of getting a green ball from the first bag? 3 green balls are there, which means 3 by 5, and we are going to take this green ball and we are going to add it there, which makes 3 red balls and 3 green balls in the second bag. And so what is the probability of getting the red ball from that? It is going to be 3 by 6. So this is the total probability of getting the red ball in from the second bag, isn't it? Now assume that the question is about the reverse probability, which means if it is already given that we got a red ball, then what is the probability that the first ball is also red? Which means they are asking the reverse probability, the probability of first ball being red given that the second ball happened to be red. This event has already occurred, right? Which means, see this, now the entire event of getting a red ball actually comprises of 2 events. One is getting a red ball from the first one or getting the green ball from the first one. Now they are asking what is the probability of this, right? So since it is already given that the red ball has already occurred, which means earlier sample space was divided into two mutual exclusive events, and then our event was scattered like this, right? And now because of the conditional probability, the new sample space is going to be this part. Therefore we are supposed to work on this new sample space, right? So we want to find out the probability of this event. So what is it? Probability of getting red ball and first time and second time, and this is the probability of getting green ball first time and red ball in the second time. Out of these two events, I want the probability of this one happening, and now the new sample space is this entire thing. How can you solve it? The same way, right? So what is it? It is equal to probability of red ball first and red ball second divided by probability of red ball first and red ball second plus probability of green ball first and red ball second, right? This denominator is nothing but this one, this entire thing. You can substitute there, right? So that is nothing but the conditional probability. You can apply it. So what is it? Probability of R1 into probability of R2 given R1. These numbers we already know, isn't it? Divided by probability of R1 into probability of R2 given R1 plus probability of G1 into probability of R2 given G1. You can substitute these numbers there and you can get this reverse probability. Again, it is an application of Bayes theorem. Got it? So one thing you should observe is what should be in the denominator. That depends on what is the event they are talking about. Let us say the question is, let us assume that the what is the probability of getting a red ball in the first draw given that we got a green ball from the second one. Then if you observe this, it is nothing but, see, one other way of writing it is equal to, I'll just tell you one more way. See this. Now we know that probability of first red ball intersection green ball is equal to probability of green ball into probability of red ball given green ball, isn't it? Now this is what they are asking. So you can just divide both sides with P of G2. See, the same way, the same one, don't get confused. I am trying to derive it from some other way. So it is nothing but probability of red ball intersection green ball divided by probability of green ball. Now what should you do here? You should substitute in this place the total probability that the second ball is going to be green. Now how can you do that? The total probability that the second ball is going to be green is equal to sum of these two events, right? So probability of R1 intersection G2 plus probability of G1 intersection G2. Again, they are dependent events, and so you are supposed to apply conditional probability while expanding. Therefore denominator is going to change based on what is given, and numerator is going to be intersection of these two. Got it? So this is where from this formula we got this. And how did I expand this one? Using the total probability theorem. Using the total probability theorem I get this, right? And then from this, using the conditional probability, I am getting this. I hope you are getting everything right. Using the total probability theorem, I'll expand this one, and then these intersections I'll expand using the other one. So what is the other one? Is the conditional probability. Okay, this is how you can solve it.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.